Howdy, y'all, and welcome to another high-powered episode of the High Voltage Live Show, the most electrifying show on social media, coming to you live from the Mile High City in Denver, Colorado. I am joined by my great colleague, James, the man Stallcup, the man with the best online academy there is. If you guys want to learn something about code, it doesn't matter if it's 70E, 70B, just regular 70. You got to go check out James Stallcup's material. He's getting ready to be registered through the states and everything. And it's going to be awesome to take your CEU course this session, sir. I'm so excited. And just to introduce all the people that's new here, my name is Willie Snyder. I run the Nat King Code page. I am here in Denver, Colorado, the Mile High City, home of the Stanley Cup champion, Colorado Avalanche. James Stallcup is over there where some college championships might be going on this year with the Hook 'em Horns over there, Texas Longhorns. So we're going to have a lot of fun, and we're going to get a lot of football going this year. So I hope y'all are ready for some good football fights this year. James is a Cowboys fan. I'm a Broncos fan, and we're going to have a lot of fun going back and forth on that. And so I just want to thank everyone who was participated with the Nat King Code this week. We had a lot of great responses. Everyone, just so everyone knows, if I give you a like, that means your comment was a good comment. You participated, and that's what the way we teach. We teach for participation. It doesn't matter if it's right or wrong. And there's some other of these code guys out there that's kind of slandering our name, seems like tonight. And I'm not sure why. If they're such good educators, why do they have to bring us down? You know, I mean, they got like 30,000 views over there on TikTok. I mean, why do they have to slander us? I mean, my Nat King Code gets about 45,000 post reach every week, but I don't slander anybody. No. So, it's pretty sad for the industry, to be going to that, but I'm not going to mention any names unless it's Paul Abernathy, but whatever, that's fine. You want to slander my name? Go for it, buddy. No big deal. You tried to steal everyone's material for years and nobody cares. It's cool. We're going to keep doing what we're going to do,
I'll give a shout out. We went over 14,000.
Oh, NEC for Dummies is doing awesome.
Gonna be 15 before too long.
And I do want to give a huge shout out. We have a ton of contractors. We have a ton of businesses and stuff that are members of the NEC for Dummies. And if you're looking for like business advice or anything, go over to Rebs, the Rebs group. They are freaking awesome. They're a residential electrical business service group, but they have so much ideas for business. Doesn't matter if you're residential, commercial, industrial. I think Clay is an industrial guy, and he's doing great. I mean, he has so many different software designs for getting in and niching out and building your business and stuff. So we always really like to have support from guys like that give you guys techniques. I think this week on Wednesday, we talked about how to respond to negative reviews for your business, and that's awesome because I'm getting negative reviews all the time and, whatever. I mean, I'm still here. Nat King Code had a great week this week. We killed it. And it's so awesome to be able to get all this stuff out here. And, like I say, I'm not sitting here trying to tell you guys I'm the instructor and you guys are the, students. What I'm trying to say is we're all students in the same field and we're all trying to learn. So I'm not trying to put anybody down or call anybody names. I mean, the 7-minute apology that Paul Abernathy gave to James Stallcup, it was pretty special, So I wanted to make sure it had the proper music to it. He just didn't have the music set up to it, I had to put "Sorry Not Sorry" to it, because that was more. It was an apology, but it was just calling us out, and so that's fine. go ahead and call us out. We're fine with that. And the myth of the week has been one of my most popular segments of all time, and it's so much fun. And all the myths are posted in NEC for Dummies group. So I always post the myth number, so you can always go in there. You can look at the myth, you can read what it says. We have a code reference in there, and then we go and we cover the myth. And a lot of people say, "Oh, that's not a myth," or "That's not right," or whatever. And maybe it's not, but just reach out to us and let us know, and we'll get it fixed. We'll, change the wording a little bit or whatever we have to do to make more sense to you or make more sense to us, because we're trying to put them out there as just having fun. And I want to give a big shout out to the Wall of Shame. We just hit like 29,000 this week. So we're at 14,000 on Dummies, 29,000 on Wall of Shame. And we're just having fun. We're just posting a bunch of hack work. Most of it's Willie Jackerson. I don't know how that dude, he says he's never failed inspection with that. And I'm just like, dude. And he's like, dude, there's no code violations. I'm like, all right. A bunch of other people say it's riddled with code violations. So hit us up if you catch Willie in some code violations. We'll put him on blast. But our myth of the week this week was a real good time. This was group choice. So the group chose this myth this week. So everyone thinks.
I'm gonna give a shout out real quick. I was over today doing a course on calculations for a lot of the inspectors here in the state of Texas from around, and we did the calculations, and I used the calculation course online. And a lot of them, they're going to join EDC for Dummies and start coming to the podcast when they have time. They were all interested in it. And
nice.
Then they all were wanting to have the monthly subscription to all the calculations. They said, nice. I've never seen anything like that. And we got excellent reviews across the board. There wasn't one that wasn't a 5-star review during that class. So
that's awesome.
Big shout out to all the boys out there.
That means a lot. I appreciate all the love too, coming from Texas. And I got some push a little bit over here in Colorado with some of the members of the Colorado State Electoral Board. So it means a lot for us to be in that deep with everyone, and that we're bringing you guys good information and that you appreciate it. And like I say, if you have a problem with anything we say, feel free to block us, or just let us know.
Yeah, that's right. All right, let's go ahead and cue the myth of the week. What do you say?
Myth of the week, baby.
It's time for Myth of the Week.
All right. Well, this is a really awesome myth that I tend to cover a lot. A lot of people seem to think that that there was some new code that passed at some point in time, like 2002, where they say you have to pull a full-size ground at every conduit. And a lot of times, I've been in the trade for a long time, and I've had companies I work for where we only pull a full-size ground up to like the first J box, and then we just use the EMT after that, and it's completely legal. There's nothing in 250-118 that says you can't do that. Here on the right, we have EMT is the equipment grounding conductor. It's kind of hard to see in that picture, but that was one of my ones that I kind of put out there as like a little Easter egg for people to find and see if they see any code violations. And everyone's like, oh, well, the code violation is, all this different stuff. But in all actuality, the EMT is allowed per code to be the equipment ground. They're like, well, what if the coupling comes apart? Well, that actually turns a 90 and goes right into that cinder block that you see behind it. So I think it'd be really hard for that conduit to come apart. So, I mean, to me personally, I don't see any problem with that one. The one on the left, this is one I was actually deemed as a perfect install by a bunch of the code people, which I was really proud about, because there's a metallic device, a non-metallic device that's in this box. So there's really nothing to bond with the device itself. It's a E-light sensor device, and it was funny about this because I just went like color to color. I was always taught just go color to color. And so it's kind of a joke that I do a lot. And so I went color to color, and then this is actually a 277 volt system. So if I was going to be colors for the building, I should have probably been gray for the neutral. I didn't really care what we were doing. I just wanted to do color for color. And I don't see any kind of code violation with 210.5 on this one. Even though the building colors for the neutral would be gray. And then the other problem with that one is that when we're coming through there, we had to come through a N-light control cabinet, and we're coming through a relay section. So per code, if I was to pull a wire through there, that wire would be required to be bonded at that relay cabinet. And so then you open up a can of worms when you do that, because now I hit the ground screw on this Foursquare. I got to go through the relay cabinet. I have to tap my own 1032 or whatever 32 thread count. It could be anything, and it doesn't have to be green either. So we might do that for one. But then I have to find a place to tap that wire type grounding conductor in that relay cabinet. And there's really no space for it. There's really no place for it to go. So that half-inch EMT comes up, hits relay cabinet, comes out of the relay cabinet, goes and hits my my junction box for the 277 volt control power that feeds this N-light device, and you're done. Piece of cake. And so that's 100% code compliant. Actually causes more problems by putting a ground wire in there. So a lot of people would look at that exceeding code. Now, here's one at a hospital we ran into, and the coupling just straight came apart. And I can't really see too close on this one, but it doesn't even look like that coupling ever got tightened ever in the beginning anyway. Like it looks like it was never even tightened. And this is the way we found it. This is not a staged photo. I went into a hospital, I saw this, and I was like, whoa. Sent the picture. So
yeah,
I thought that was pretty interesting, and it probably had a ground wire in there. It should be good.
Well, what I did, I put a little diagram together. Well, we actually had a diagram. I just got everything in color and all that. And when you look at
sweet,
when you look at 250.118 and you look at your types of equipment grounding conductors, you'll see in there that it lists EMT and then it talks about the others. But you'll notice we talk about the EMT, and I've got it highlighted there with an arrow. This is just exactly how it looks in the design book. And we talk about it being a combination use here with the equipment grounding conductor. And I'll give a little backstory on this.
Nice.
It was probably about 25 years ago. I don't remember how long exactly, but Dad was on a case. He was actually a special expert for OSHA. And what happened there was, I think it was an HVAC guy, if I'm not mistaken, but they had, like you were showing in the previous picture, where a coupling, it came loose at the coupling and it was separated from it. And of course, they were using the EMT as an equipment ground, and it wasn't clear. So what happened was he was up there, he grabbed something, and he reached up, grabbed that pipe, and then of course he got that current. And when that happened, is his weight that pulled him off, and he fell to the ground, busted his head up and everything. So naturally it went to court and everything. And their special expert got up there and At that time, he was referencing 250 dash 96B, I think it was, or 94B, one of those.
Yeah,
But
sounds right.
I think it's 96B. But
Yeah.
he had taken and showed where the EMT could be used as an equipment ground, and so they went through their whole spiel, and then the attorney that was for OSHA, Dad put down what he wanted him to ask, and he asked him at that time about 250-50, which now you'd look at 250.4, but it said that the equipment grounding path had to be continuous and permanent. And when he asked him that, he said, well, it was at the time of the installation. Well, that didn't cut it. So,
Dude, if you don't see that mark on the conduit from that set screw being tight, then dude, you're gonna have a hard time in court.
oh yeah, well, they classified at that point that it wasn't continuous and permanent, and a couple $1 million later that they lost that suit, you started seeing a lot of engineers and facilities and stuff. They started requiring they want an equipment grounding conductor pulled in that EMT.
Yeah, so I got a story that I heard from some of the Facebook groups. What happened was there was a plant. We do this a lot. There was a plant. They have their own maintenance contractors that go in and do stuff, and they're not licensed or anything, but nothing is like a code violation for these guys to like work on electrical. They're hired by the plant. They're allowed to work on the plant and everything. But every now and then, the guys who run the plant are like, you know what? I'm gonna get the licensed guy in there. So these guys, they hire a licensed guy to come in there and run a bunch of pipe for a new conveyor system. So this guy, he's licensed, real cocky dude and everything. And so he comes in there and he says, yeah, you don't even need to pull grounds because the EMT's ground. So all these maintenance dudes are like, dude, this inspector is gonna fail this guy, man. I can't wait till this guy comes in here. So he goes and he runs thousands of foot of pipe and everything, EMT and everything, and gets it all done, gets all the wire pulled, and he's ready for inspection. Well, he pulls a panel cover, and this is a de-energized panel, so it's electrically safe work condition, for the inspector. And the inspector notices he didn't pull any equipment grounds in any of the raceways.
Right.
So all of a sudden he looks down, and they both look down, and they see a set screw on the ground. And the inspector picks it up and like, hey, dude, tightened all the set screws, right? Oh, yeah. He goes, yeah, you know what? He goes, I'm not really believing you. He goes, I want you on Saturday to come back. I want you to go through all this pipe. I want you to make sure you tightened every set screw. All right. Well, yeah, I guess. And so then he goes through and he comes back on Monday and he tells the inspector, yeah, man, I went through this whole entire plant, man. Not a single one was loose. And inspector says, yeah, well, he goes, it's for guys like you that I carry a pocket full of set screws. It would have been cheaper for you to just pull a ground wire.
Mm-hmm.
So a lot of times the inspectors, they try to pull that whole thing. And, the thing is like, yeah, technically per code, you can use the EMT as an equipment ground, but all the fittings have to be tight. So that's why I showed that one that came loose at a hospital. That would actually be a violation, even if you have a ground wire pulled through it, because you're trying to use a 517.13. If you're in a patient care area, you have to have both of those paths. You have to have the bonding path and you have to have the grounding path. So That was kind of why I wanted to post that, why I sent that picture to you today, because it's really important that people understand that you have to have both of those. You don't just have to have one. So in a lot of cases, you only have to comply with 517.A in a medical facility. And the 2020 code change was really good. I thought the 17 was kind of bad, poorly worded to where you have to comply with A and B. But now with the 2020 change, you have to only comply with A, which is just your typical, equipment grounding conductor. And I think this was a really good myth to cover. And if you guys have any questions in the comments, post them up. I do want to give a big shout out to James for setting this whole thing up. And if you guys don't want to miss any of our content, feel free to subscribe to the Bolt Online Academy, ring the bell, and hit the like so more people can enjoy our content and get involved in what we're doing. And like I say, this is probably more geared towards advanced code people, more advanced electricians. But, you know, even the younger guys, like I have a lot of apprentices that really want to be here and like learn this stuff. So welcome you guys too, you know, and if there's any questions you have even later, feel free to hit them in the comments on this video, and we'll get back to you and let you know, like, hey, yeah, you're right on this, or no, you're wrong, or whatever. It doesn't matter. We could be wrong on some stuff. We could be posting out some wrong stuff.
Yeah, if you look at the illustration, just to give an example, that if you look at the RMC and the IMC, you'll notice I'm only showing a black and a white conductor.
Right.
And the reason is because that's all threaded. It ain't going to come loose.
I don't know. It looks like that arrow's pointed to the wrong thing on the. No, I'm just kidding. I'm just joking.
I have done that before.
I'm just kidding.
But it gives you a good example looking at the different wiring methods. We're showing where you'd want to pull that equipment ground in, and showing one where you would take and use the conduit where you feel it's not going to come loose, and that's a good example of it.
Yep. And to be honest, EMT that doesn't even have a set screw tight in the fitting is probably going to be just as good of a ground as a equipment grounding conductor in there. But without that screw being tight, it's not assured. It's not an assured grounding path.
No, and plus, if you're in an area you get vibration, especially over time, it'll come loose.
I've seen vibrations break stranded wire connections.
Oh yeah. That's why I tell people just look at it. But this is a really good illustration. Gives you a set of what we're talking about and everything. And that's
absolutely
that illustration there that come from the design book.
Well, and I hope that all the members of NEC for Dummies enjoyed it this week. That we put out a special one. This was that you voted for. And next week we might vote. We might just choose one. I don't know. But it's been a lot of fun to do this. And it's been really cool to be called out by some of the top code people like, oh, no, whatever. And I'm not talking about Paul because he's not top code dude. But whatever. I mean, you know, it is what it is. I mean, you know, I just got a little freaking hot, like getting called out right before we went live. It's like, really, dude? Like, you blocked me and you're still mad at me? Like, well, I'm just living rent free in your head, man. And
yeah.
He's even mad at Willie Jackerson. I'm like, dude, Willie is a freaking known hack and he never gets called out for it. He passes every inspection. I'm like, dude, I don't see how Willie does it, man.
Say, if they're talking about you, you're doing something right.
Yeah. And shout out to Mark Candels, because it was really cool talking to you, brother, about that same exact thing.
Awesome. All right.
Yep.
Okay, well, let's set up and let's go to topic of the week, where we're going to be looking at doing fire pump calculations this week.
All right.
Dad likes that. He thinks that's funny as hell.
All
right. Now,
I'm not. That's one man I'm not going to argue with.
Oh no. Now, we had actually gotten requests to do this, and actually wanted to be able to. I just didn't have time. I thought we had an illustration of it, but we didn't. But I'm going to take 1 week and I'm going to do some voltage drop calculations, and then I'll go
Nice.
tie the voltage drop portion into fire pumps, because when you go over there and you look at your voltage drop calculations, it's going to tell you that you're going to have a 5% for the voltage drop, but then that's for the starting. Now, when you get into the running portion of it, it says 15%, and that's where you got voltage drop, and then you got voltage drip, is what the way we like to classify that. And I'm actually going to show that taking care of voltage drop, but we're also going to show when it's in the running mode how you do it for the drip portion of it, to make sure, because when you're sizing your conductors and overcurrent device for that, you want to make absolutely sure that those conductors don't burn up, and you also want to make sure the overcurrent protection device does not trip. In other words, they'd rather the motor burn up than it trip, or the conductors burn.
Yeah, so there was a bunch of questions that came in on my side that I tried to convey to you, and I'm not really that good at conveying the questions like the way that they were conveyed to me. So any of the listeners out there that asked these questions of us to cover, I apologize. I tried to do the best I could as far as conveying it to James how he wanted to, portray it. We have another episode that we did on voltage drop, and we kind of covered this. We touched on it a little bit. I think that's where a lot of the questions came from, and I think the way they were asked, I didn't really convey them good to you. So we're gonna work on that in the future and just get kind of a better way to cover the questions, to where we're not just making up our own crap like some of the other guys do. They just make up their own questions and then just answer them. We're not going to do that. We want you guys to send us the questions, and then we want to answer how you guys want us to answer them, as far as what you want to understand with it. This fire pump calculation one is the only section, literally one of the only sections in the code where voltage drop is required. So a lot of people get confused on that. They go off, I think it's 210-19, 210-20.
Well, it depends on if you're doing it for a branch circuit or feeder.
Yeah, but you go in there and it'll say that you either have to be 3% or 5% or 3%, 5% combined, but that's not a requirement per the NEC. All that is an informational note.
Right.
So a lot of people don't realize that. I mean, if you go into AC units, manufacturer says should not exceed 9%, which to me, that's amazing. That's a huge. I mean, if you can't get a branch circuit under 9%, then just don't even be an electrician anymore. I mean, to me, that's crazy. I mean, I've seen circuits go in 5%, 6%, and I'm thinking, wow, that's crazy. And then I went and did all the testing, and I'm like, wow, it's only 5%, So, I mean, I thought, wow, 5% is a lot. Now, all of a sudden, the manufacturer says if the voltage doesn't drop below 197. So, when you look at it, I mean, it could be a problem. We ran into it before with low voltage conditions in schools. And what happened was we had a big chiller compressor, and it was running a lot, and they had this huge demand on it. Well, what happened was when everyone called for the demand on that cooler, what happened was it would drop the utility. So the utility coming in the building would drop from 208 all the way down to 196. And then everything worked fine. Everything in the building still worked fine, but it killed that compressor motor.
Right.
So the reason it killed that compressor motor was because it was below the nominal voltage that it was designed for. So what we ended up having to do is put a buck boost transformer in there, boost it up to 230 volts, and then feed it with 230 volts. And then when it hit a huge demand, it wouldn't lag on that buck boost transformer, it just lagged on the whole system. But it dropped like probably 30% of the lag on the whole system. So like everything worked better.
I actually show a calculation with the buck boost. So
nice.
You know, it was interesting
Yeah.
because I went and I was looking and I saw there were articles of 695 and they mention the calculations, but they don't show you how to calculate it. And I found that interesting. Of all the information that's online, they wasn't showing that. So,
Wow.
but we've had this in there for a while, or else I just couldn't find it. It might be on there, but I didn't see it.
Well, I think there's one person that's going to have a code change book out before everyone, and I think it's going to be Volt Online Academy is going to have the first code change book that's produced.
Yeah, we usually have ours always ready first September, second week of September when the code starts going out. And the online portion of the course will be ready probably right about October, end of October, when everybody else is coming out with their publication. I honestly feel like sometimes they wait to see what comes out so they know what to put in theirs.
Yeah, it was really funny because I noticed that there was like in some of the other things that they put out, they skipped pretty much like everything like chapter 3, chapter 4, and then just like went into like swimming pools or whatever, you know. So it's like certain code making panel, maybe, you know, give them like certain things. But just make sure you drop that link on NEC for Dummies because all our members are going to want to get that. Like, they want to be the first to get that book.
I will. Now,
that's going to be awesome.
As we get into this, when you go over and look at 695.3a, what you're going to get into, it's going to talk about your different power sources, where you got the utility, transformer, and on-site power production. And this is just sort of tying this in because they are going to recognize the power sources that are going to be feeding the power pump. Okay.
Gotcha.
It's not a hard thing to explain, but I just wanted to start there because this is where we're going to be talking about the fire pump and feeding it. And then you'll see the power supply coming over there to the fire pump controller and of course to the fire pump. And it's
and keep in mind that is rigid conduit that's feeding that too, because it's likely to be it has to be protected from damage.
Sure. Now, one of the things we're going to look at first is sizing the conductors over there. And you're going to see one of the things everybody has always liked about our illustrations is we give you sections that are going to tie it in. So if you look right there where it's talking about sizing conductors, you'll see 430.22, 430.24. That's if you got multiple. And then 695.6B1, that's going to tie this all together. And this fire pump, we're going to be looking here. The motor is 60 horsepower. It's 460 volts, three-phase design B. Okay?
Right.
Now,
and keep in mind, too, that a lot of these fire pumps, there's really no PPE that you could use to work on those energized. So just wanted to tie in that 70E reference that they're not likely to be worked on while energized because they're not, they don't have order protection devices that are sized for personnel protection.
Right. They're sized to hold it indefinitely.
Absolutely.
Now, when you look at this, you know, I always tell everybody when you're getting in and you're sizing stuff, when you looking at a motor and you go over and look at 240.4G and you pick up your specific conductor application, it talks about when you're sizing motors to go over and look at Article 430, and then it's just going to have all these parts there to go look at. Okay. And when you go over and look at 430.6A1, when I'm sizing conductors or overcurrent devices, it tells you to go look at tables 430.247 through 250. In this case, since it was a three-phase, I'll go over and look at table 430.250, and for that 60 horsepower motor, it's going to tell you it was good at 77 amps. Okay. Now, when I size the conductors, 430.22 and 695.6B are going to tie into each other. And if I'm sizing the conductor to one motor, what do I take it at? 125%. So I'll take
Oh,
77.
you got a freaking tornado coming in over there.
I don't know what's going on. I'm not worrying about it. But if you take 77 amps at 125%, that's going to give you 96.25 amps. And then all I'm going to do is look at table 310.16. In this case, we're going to say they're 75 degree C terminals. And the next size above that for the amperage is 100 amps, which is a number 3 conductor.
Nice.
Okay. Now, if I'm doing a single motor, guess what? I'm doing it the same way. It doesn't even have to be a fire pump motor. I'm still applying the same principles on that calculation.
Right.
Okay. Now, the next thing I'm going to look at here is I'm going to be looking at the overcurrent protection device in the panel board. And you're going to see here, it's going to reference here 695.4 B22A. Okay. And 230.94A4, which is going to refer you and tie this in when I'm looking at dealing with fire pumps. Now, when I get over here and I look at this, it's going to tell you that you still use the 77 amp for the overcurrent protection device. But when I go look at 695.4 B22A, it's going to tell you here that I'm going to take that at 600%. Okay.
Oh, wow.
Yeah.
Okay.
So when you do this calculation for that overcurrent protection device, and if you look, there's a note up there where it used to be in previous editions, and we tell you the 600% times the full load amperage there, that fire pump was in the 1996 NEC and previous editions of NFPA 20.
Hey, so code's just the minimum. Can I just go 1200%?
600 is good.
All right. Cool.
Now, so
I'll
I'll
say
take
600.
that's 462 amps. And then when I'm sizing the overcurrent protection device, and how many times have you heard me say this? When you do a percentage, they've kicked this up quite a bit. But I said, if you're over 125%,
Go
any
size
percentage
down.
over that, I size down. Well, what did I do here? I went to a 450 amp overcurrent device.
Dude, freaking genius.
Yeah. Now, watch this. Now, this is going to be where I'd be setting up and doing a buck boost here and kicking it up with a transformer. In other words, instead of doing voltage drop here, we put a transformer in here.
Dude, that satisfies the language.
Yeah.
Nice.
And what you'll see here is I've got an 80 kVA transformer, and it'll tell you here, shall be rated to carry 125% of the secondary currents. And we're going to look at this in just a minute. Now, the primary that's coming over there is 4160 3-phase. And we've already done the work here for you, telling you what these secondary currents and everything are. But on the secondary, it's 4277 volt secondary 3-phase. And you're going to see secondary currents there. We're going to tell you the locked rotor current's 320 amps. I'll explain all this in just a second.
Okay.
Then we're going to tell you the full load current of the motor is 52 amps. And then we're going to tell you there are other loads that are being supplied here also that is rated at 30 amps. So we've already made all this up. Now, the other thing I want to point out, because you're going to see this in portions of the calculation in just a minute, is I have to take that 4160, and because I'm on the secondary side, how many times you heard me say this when I'm going over there, I need to get the ratio.
Yeah.
So I'm going to...
A quick question. This is a stupid question, but this is from one of our users on another site. They're saying, do you have to selectively coordinate for that application so that your overcurrent device doesn't trip at that 600%?
Well, no, you're not selective coordinated because you're sizing it based on the locked rotor current. And in other words, it's going to hold indefinitely.
Okay.
Now, if I look at this, if I take that 4160, divide it by 480, you're going to see you have a ratio for that transformer of 8.67. Okay.
Okay.
And he'll understand it, whoever's on the other, because I'm going to do the calculation. Now,
It's one of my buddies.
okay, now if you take and look, I've got an arrow down there, and we're talking about the primary overcurrent protection device. And this will tie specifically in with 240.4A also, 695.5B. And it says that overcurrent protection device is sized to hold the locked rotor current indefinitely. Okay.
Right.
Now, if you look at note 1, where did that 320 amps come from, that locked rotor current? Well, if you go over and look at table 430.251B, it's going to tell you that locked rotor current was set at what? 320 amps.
Right.
Okay. Now let's look at the calculation and break all this down. This is the last thing we're going to do here.
Okay.
Now, you're going to see, I'm going to look at sizing the primary overcurrent protection device in step 1, but I also want to point another thing out. Right over on the right-hand side, and this is something we do for a lot of our calculations. We'll have a lot of quick calcs in there to help you move along when you're trying to take and do your calculation.
Hey, if there's a meme that comes out against you, I don't know what happened to it, but it's going to be like, move along, sir. Do the calculation and move along, sir.
That's okay. Now, if you look there, you're going to see quick calc 1. Just go look at the table. There's your locked rotor current. Now,
Yep.
quick calc 2, I'm going to look at what size transformer would I need for this. Okay. So I'm just going to do a transformer calculation to clarify the size transformer we're telling you to use.
So now this is only in the case of like a 208 3-phase that's buck boosting to 240 or 230, or could it be any kind of application?
Well, in this case, we're showing one where we're doing it for a separate drive system.
Okay, so it doesn't matter the voltage.
No, it doesn't at this point, because the separate drive system, we're going over 4160, but
Okay.
we're going down because it's a 480 volt motor.
Okay, gotcha.
Okay?
So you're doing 4160 to 480 volt. Okay, gotcha.
Now, if you look at this, we said we had 52 amps. Okay, that was your motor load. Now that motor has to be taken at 125%, and that's going to give you 65 amps. Then I'm going to add the other loads on there, which is 30 amps, and that's going to give you 95 amps of load. So what I'm going to do here is I'm going to determine what the kVA is here. So I'm going to take that 95 amps. The secondary side of that voltage was 480 volt 3-phase, so that'd be 831 once I multiply the 480 by 1.732, and then I'm going to divide 1,000 into that, and that is going to give me 78.9 amps. And then I round up, and it's going to tell me the transformer is required to be rated at least that's got 60 there. That should say 80 kVA.
Okay.
I was doing that so fast last night. I just
Dude, I will tell you, I think it's awesome. Like when I could just call you up out of the blue and be like, dude, how many number 12s can I get at a 3/4? You're like, you know?
I get calls like that all the time.
The thing was that it to me, it's really amazing when you can go in there and calculate all this. It makes us smarter electricians when we can go in there, we can calculate all this, and the engineer says, hey, just go ahead and do this. And then you just have this easy math in your head. And
Sure.
I love this. And the number one thing that I love the most, guess what it is? The number one thing I love the most about this. What is the reason for the times 1,000?
Oh, yeah.
Like we went through this, and like we got attacked hard for that times 1,000 thing for a constant.
But we proved it.
what is that times 1,000? Tell everyone.
Are you talking about for which one you talking about? So I can
The voltage drop for times 1,000.
Actually, that's divided by 1,000.
Okay.
That's why we said times. I was like, oh wait, yeah, the dividing into 1,000, and all you're doing is taking the VA that was up there, divide it by 1,000 to put it in amps. That's
Right.
what we were doing.
Absolutely. And I love that whole thing that you brought that into that easy math thing for me. And it means a lot, sir. So
Well, thank you. Yeah.
yeah.
We always do our calculations, and I always say it's easy math because we do everything in VA, and then we divide into it. And if we have to do 1,000 to get that, if we're in KVA, we do that to get it in VA. So once you got it in VA, then you can take the voltage and put it into amperage real easy.
Yeah, so for the people that's watching, you have to make sure that you do the divide and the multiply the right way, because if you're doing divide and it comes out weird, then you're like, oh, okay, maybe I should have multiplied. And if you do multiply and it comes out weird, you're like, oh, maybe I should have divided. But that's what I suggest, is to take the answers that you have on your test and put them in your formula and see if they make sense.
Sure.
Because if it doesn't make sense, then it's probably wrong.
Right. Now, when you look at sizing the primary overcurrent device there in step one, we're going to do the conductors first. And what you're going to notice here is I'm still doing the same calculation. You got the one motor there, you take it 125%, gives me 65 amps. Then I have my other loads at 30 amps. Add that together, gives you 95 amps. And naturally, the next size above that's 100 amps, which is a number 3 conductor. And right below that in the note, we tell you the transformer has to be able to carry that normal current rating of 95 amps. Okay?
Right.
So now what we're going to do is we want to make sure that we're sizing this overcurrent protection device here, because I am coming off the secondary side to indefinitely hold that locked rotor current. So what you're going to do here is you're going to take.
I really love what you're talking about. I mean, we love to indefinitely hold stuff on.
Oh yeah,
but you have to watch out the arc flash rating on that too.
Yeah, well, yeah, that's getting into 70E on that.
Yeah.
But when you look at this, and I didn't see this online or anybody showing this, but you'll take the locked rotor current, which is over in table 430.251B, and it's going to tell you that locked rotor current was 320 amps. And then I showed where you took the 4160 volt, divided by 480. That was your ratio of the transformer, which was 8.67. Divide that into 320 amps, and that's going to give you 39.5 amps. And then the next size above that is 40 amps. So on that secondary side, I would at least have to have a 40 amp overcurrent device to hold that indefinitely based on that locked rotor current.
Hey, that's awesome.
And, I've seen a lot of them come in and talk about stuff like this, but I've never seen them take and go into the in-depth complexity of the calculation and how to size that overcurrent device to hold that locked rotor current like that.
Yeah, dude. You guys are definitely one of the top people in the industry, from my understanding that I've seen, and and you've seen them attack me a lot, and the whole thing is like, that's fine, go ahead and attack me. I mean, to me, that means I'm doing something right, man. To me, like I'm challenging people, I'm getting people thinking. I mean, if I got code making panel members attacking me, like that's pretty awesome. I mean,
something I'm going to do also here is I'm going to take this portion that I'm showing right here in this calculation, and I'm going to take and do, based on this right here, I'm going to take this and I'm going to add a length here without the transformer, and do a voltage drop on this based on that running and starting current for 5 and 15%, and showing that conductor size based on that.
That would be sweet if you could actually get like a point at the motor doesn't start. That would be pretty sweet.
Well, I want to do that because we didn't even have that calculation short, and I thought we had every one of them. And so I'm going to do one and put that together, and I'm actually going to add that once I get it done to the generator transformer motor compressor book. and I'll add it at the end of chapter 20 after we show that calculation. So I'm going to put that in for the 2023 cycle.
Dude, that'd be awesome, man. And like I say, this whole show has been really fueled by all the people that watch and all our viewers, and it means a lot that people like directly reach out to me and say, hey, ask James this question or whatever. Feel free to ask us any questions. We're not going to attack you publicly on the air like some other code people do, but
Yeah,
like I
that's
say,
anything. If I don't
yeah,
know, I'll just say
I
I'm
mean,
not sure about that, and I'll find the
yeah.
answer out.
I mean, it's really, to me, it's like, who cares? Like, I want to learn. I'm asking like the dumbest questions ever. I'm like, do you have to mix that mud together to spackle it on the wall? I'm asking the drywall guy questions.
Oh yeah.
Like, I don't care. Like, I don't know. I'm like, dude, how do you get that insulation to fit like that? Whatever. I don't care. I mean, and then it's been really awesome for me to bring the Nat King code into the spotlight. We had 50,000 post reach this week, which was amazing to me. I mean,
It's going to get more.
yeah, I mean, it's crazy. And to me, maybe I need to start going on TikTok and start doing some TikTok videos and like bring them up there, and maybe start showing how like maybe I just need to start exploiting Willie Jackerson's techniques on how he passes inspection or something. I don't know. Like, I don't know how he gets by with it. Dude, he's got to be paying off the inspector, man. I mean, there's no way he gets by with that.
All right. Let's code changes. I was trying to think what the heck's next.
Yeah. No, dude. Where are you at? Where are you starting at this week?
I don't remember. I'll be honest. I
Okay.
didn't even look. I just knew what the next one was, and it's 220.50.
Okay.
Now, this is still the same section, but what happened here was there was some clarification that has taken place here.
Dude, this whole entire reference is a change, right?
Yeah. All they did is they added and air conditioning equipment. Then they sort of reworded motors and talked about the conductor sizing for both the motors and air conditioning equipment. And it's telling you where to go in order to do these calculated loads.
Wow, there might have been some people confused on that, I guess.
Yeah, well, the reason that this is important because this is going to go in and this is going to do a full clarification when you're looking at the motors when you're doing this. So in other words, since they added this here in 220.50, if that AC unit motor is larger than the other motor that you're calculating there for like a commercial installation, then that AC unit would be the largest motor when you're doing 220.14C.
So this came through code making panel 2, right?
Yes, code making panel 2.
Okay, cool.
All right, now that's the way I sort of take that with it being placed in 220.50, and we're going to reflect that in our full calculations.
All
right. Now this is one that I talked about the other day, and when you get in, you look at this, it talks about applying a demand factor of 75% to the nameplate rating. And it talks about where you have 4 more appliances rated at least a quarter horsepower greater or 500 watts or greater.
Right.
And then it goes in and it says, this shall be permitted for the 1 family, 2 family, or multifamily dwelling. And then you're going to see this demand factor shall not apply to the following. And remember when I was going over this and I was talking about 220.53 and we were talking about a full calculation. I said, you'll do your general lighting and receptacle load, and then go in and do your cooking equipment loads, your dryer loads, and your non-coincident loads. Everything else that was left went and fixed appliance. And we were asked this question. Somebody said, what about electric vehicle supply equipment? And I specifically stated, if you do not take and have it listed here, then it went into the fixed appliance load. And based on earlier editions, that's how we do it. But here They're telling you now the electric vehicle supply equipment is not part of the appliance load in 220.53. So I'm going to have to calculate this load separate.
Right.
So what we're going to do is we're going to add the electrical vehicle service equipment. We're going to add that as another step. So instead of having 6 steps, we're going to have 7 steps. Instead of 7 steps in the commercial industrial, there'll be 8 steps doing your calculation.
Okay.
Did I say 8 groups? And we'll show the electrical vehicle equipment, and we're going to show that being added into the full portion of the calculation. Okay?
Right. And it shouldn't change too much at all.
Not a lot, but the fact that they require that, and you go and look at Article 625, they're going to be over. And it also will tell you when you take and you get that electrical vehicle service equipment there, since it is considered a continuous load, we will have to take that at 125% when we calculate it.
Right.
You know,
That
it
makes
was
sense.
interesting because I was doing the class today and we were going over motors, and I was saying you take the largest motor at 125%, all other motors at 100%. And one of the guys said, well, what if the motors, you got 2 of them that are continuous? And I said, oh yeah, I know where you're going with that. I said, if you go over and look at table 430.22E, there's demand factors that are applied there, and it tells you take that continuous load and you could have an intermediate, a varying duty, something like periodic duty, and table 430.22E covers that, and those wouldn't be 100% anymore because you have a certain type motor that you need to apply a percentage to.
Yeah, and I thought it was really funny when one of the listeners was like, "Hey, what's a motor?" You know, but it's really funny because
That's
they
me,
always,
motor.
yeah, they always make fun of your accent, but it's really funny.
Y'all need to quit making fun of me. It's very
Hey,
hurtful.
hey, it's not me, it's y'all. It's not me, it's y'all.
Y'all. Now, this one here, this is not that big of a deal. This is 220.56 kitchen equipment. This would be commercial. This would be like in a school, restaurant, or something like that. That's part of our calculations where you're looking at 220.86 and 220.88. And
Right.
when you get in here and you look at this, you'll notice they put the same language in here that's been added, just like you would look for your fixed appliance load.
Okay.
And they're basically telling you that this is equipment that's considered fastened in place and rated a 1/4 horsepower or greater or 500 watts or greater. If I go back here and I looked at the fixed appliance load, and you look up here, see right here where it says 4 or more appliances rated a 1/4 horsepower or greater or 500 watts or greater,
Yeah.
same language.
Okay.
The only difference is this is where I'm doing a commercial calculation here for like a school or a restaurant.
Okay. All right. Yeah, that makes sense.
And then right here, you'll see where they went in and they added 220.57. And I couldn't remember the wattage today on this, but I said, when you're dealing with electric vehicle supply equipment, it comes in and tells you that the load has to be at least calculated at 7,200 watts or volt amps, or the nameplate rating of the equipment. So you'll have to do 2 calculations here to determine which one is larger. And based on
Right.
that, that's what your amperage will be. But based on Article 625, these loads have to be taken at what? 125% on that nameplate.
Yeah.
Okay. So that was a change that was there. And this comes in and gives you an example here as 7,200 being the minimum requirement. And that is based on a 30 amp, 240 volt single phase circuit.
Okay.
Now, the next one here is going to get into non-coincident loads, and watch what it says here. It says, I'm going to actually look at the second part of the sentence, is the one I want to deal with. It says, if a motor, now look at here, they added our air conditioning load. Is part of the non-coincident load, is not the largest of the non-coincident load. 125% of either the motor load or air conditioning load, whichever is larger, shall be used in the calculation.
Yep.
That That is a clarification on the non-coincident load between your heating and AC.
Yep.
And that's just clarifying what they did over in 220.50. Okay.
Yep.
And that's
Awesome.
why I said, since they put it in 220.50 and did this work here in 220.60, since it's in 220.50 now, when you're doing the largest motor load and adding 25%, that air conditioning load could be the largest load.
Yep.
Okay.
I agree.
And that is your 5 changes this week.
Wow, dude, you did it under an hour this week.
Well,
Oh, you did it right at an hour. But that's pretty cool.
If I would have had time to get the voltage drop in there, it would have been another 15, 20 minutes.
Well, we could do that next week for like our topic, because I really do enjoy that. And the thing is that was the question that was asked to me, and then I kind of portrayed it to you and said, hey, can we do this? And so I didn't really. I'll take the blame. I screwed it up.
Well, what I'll do is I'll do it after I finish writing the code changes, because I'm gonna have to make that whole illustration up, and I got a lot of stuff going on now.
So for all the listeners out there, all the viewers, keep in mind we're doing this for you guys. So the questions that you ask us, we're putting them together for you guys, so that we're answering your questions. Like, we're not answering our own questions.
Yeah, and when I'm doing something like that, it's got to be fully illustrated with the step-by-step procedures, because I am going to add it in the book. It's not going to be just something I throw together and show. It's going to be a full blown out process. And that one of the things Dad and I always like to do is make sure we're showing you how to do all the calculations. It's sort of like when you look at a transformer and we show you and you're in a high altitude. I hadn't seen that in any other publications, but it's a full blown out illustration. And then we show you how to do it step by step in the calculation to make sure it transformer size properly.
Yeah, and that's really good information that you have that nobody else has, and that's the whole reason why we're bringing you guys this show. Is that there is things in the electrical industry that are not provided to you by your employer, by anybody. And we're not trying to tell you to like disregard your employer, disregard anything that anybody's saying. What we're trying to do is, this is alternative thinking that's outside of the normal electrical thinking. And all we're doing is showing you what the code says. If your boss wants to go code times 5, go for it. We don't care.
I'll tell you right now, it's like the inspectors that were there. They were saying they're getting that calculation courses, and they're telling me when we're on the job like that, that makes a big difference for us, because when we're out there, if we're unsure of something, you can pull up the calculation. The form is already set. You don't have to use the values that are in there. Those are just exercise problems. And I actually did today. And I said, let's just make a problem up. It had nothing to do with this that was in the illustration. And I just made a problem up, went through it, showed them where to go calculate it. And they were like, well, heck, I can use that on the job. I said, yeah. And the inspectors loved it. And they were like, when are you going to get another thing done this? They were like, we want to get access to a lot of this stuff. And I said, yeah. I said, that's so, the theory behind the way it's been designed.
Let me ask you a question. Are the inspectors like okay with 10s on a 50 now? For like AC units?
You want to hear something funny? Today happened. We had a guy in there, and I said, I started off, I was doing the overcurrent device first, and we actually got over and we were doing an AC unit. And I think I showed where it was a 30, 40 amp. I said, I've got a 30 amp breaker there. I said, what size you think that conductor is going to be? And 5 of them in there, they said, number 10. And I said, okay. I said, let's look at that. And I just did it. I had the calculator there, and I told them where to go look and everything. I said, take it 125%, blah, blah. I said, what size conductor does it need now? And they go, number 14. and we went through that calculation, and one of the guys, he come up, he goes, I have a journeyman license. He goes, I'm ashamed to admit I did not know that. So that's
Dude,
why
a
we
lot of
provide
them.
this stuff so people understand it. And
Hopefully we didn't ruin anybody's TikTok videos.
yeah, well, one of the things that I try to show people is don't take my word for it. Anything I ever tell you, look at the sections, see what it says, and we show you where we got that information from. Then you make a decision. And everything I did today, I gave them the rule of thumb. I said, if I take anything at 125% or less, I go up to next standard size overcurrent device. Anything above that percentage, you drop down except for phase conversion because you got to protect the conductor. And then for transformers, and it has a C note 1, gives you the option to go up or down. By the time I finished the end of the day, everybody was going, yeah. He goes, he proved it. And I showed them the wording and everything. And they said, I've never heard that before. And, of course, I got all 5 stars on the class, but the reason I did is because I'm showing them and giving them information and techniques and rule of thumbs they've never been taught. And that's one of the reasons that I tell people, get that that online stuff, because all that information is there for you to learn. And my whole goal through all this, one of the guys, he asked me, he goes, how much is it? I said, $39.99 a month. He goes, for all those, he goes, how many calculations? I said, there's about 250, 300 somewhere. I said, I don't remember how much. And he goes, for $40 a month. I said, yeah. I said, you got to remember, I said, I don't have like a big corporation where I have to pay all these employees to do all this different stuff. I said, I did everything. And I said, I make it affordable for the industry. And
dude, some of these guys are charging people like $500 a pop, and then you have to get a 1-year subscription.
Yeah.
And then they're like, you can't even get this video. Like, you can't even get the video from us because we're going to go, oh, you're not a subscriber. Like, really?
I was asked that. They said, how much do you charge to cover your podcast? I said, nothing. They go, it's free. I said, oh, yeah. I said, come in, ask anything you want. I said, that's what we do it for. I said, the way I look at it is I'm helping people out. And, they say, oh, wow, he does this for us. And I'm taking his update on his license, his courses, and I make a little bit of money. I'm happy.
So the one thing I am going to complain about, I think you owe me about 30 code
changes.
You
need to shut up about that. You say that every damn podcast.
All right. No, I'm just kidding.
I know. I know
you're me up, brother. I'm just
kidding. My chain. That's okay. I'm used to it.
No, I'm pretty good. Your course was the best in the whole industry, and there's nobody else out there that I could say owes me code changes. I mean, some of the guys, they go from article 2, from chapter 2 right to chapter 4. And then you're like, hey, where's all that chapter 3, whatever, where's all those changes? Well, they don't know them, so they don't want to teach it.
Well, I won't say any names, but you'll see some.
I know what name you're going to say, but yeah. I'm not going to say any names either.
I'll just say he doesn't even write his own books. He has ghostwriters. But what we do, we come out in September, then his will come out the next year sometime.
Well, and a message for him, the Article 100 is going into all the definitions are getting moved to Article 100, whether you know it or not, whatever. It's not ANSI standards.
And a lot of people know he was on NEC Live, and he was doing code changes in 45 minutes. He was already in chapter 6. Heck, I just did 5 right there, and it took me 15 minutes to explain it.
Yeah.
And I didn't even go in depth. When you see the illustrations and everything put together, like a couple of those, we would have showed a calculation, going through the calculation, showing you how to apply that electric vehicle supply equipment to that calculation at 7,200 watts or the nameplate rating. We would have showed you that. Now, if I'm doing that, now all of a sudden that 15-minute presentation I did on 5 of them now starts going up to 45 minutes.
Yeah, and we're not trying to bore you guys with long presentations, but we are on a little bit longer than an hour. So we should probably go to the tour review.
Tour review. Let me cue it up, brother.
It's time for Tour Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right, so we have a reoccurring tour review. This is this was our gift for the lady apprentices. This is a gift for Kirsten that we sent to her, and it took her like 16 months to get it, but she finally got it. It was during COVID time, and it was really hard to get things through the mail. I'm not trying to make excuses, but I was really busy at the time. But this has proven to be a really good tool. She really likes it. I texted her back a few times, and she says she really likes it. This is like a precision screwdriver kit. So it pretty much has everything that you're going to need that you can put on there and everything. The only thing I would worry about that I don't like about these kind of things is that if some of the little attachments like come off, like while it's like an energized terminal or something. But that's the only thing I don't like personally, but I don't know how strong the magnet is on there, but she says she likes it. So, to me personally, I just want to give another little shout out to the Lady Apprentice group and say we're really happy to have all the ladies participate in our code challenge. And it was a lot of questions put together by James, and it was really awesome to see this kind of come full circle, give out a gift that was like, we call Kirsten like a shop rocket. So she knows that she's a shop rocket, but shop rocket's like somebody that goes out there and does a really good job in a short amount of time. I think she answered like 50, 60 questions in like 2 days or something. So we're real proud of her. She made us proud as from the Volt Online Academy, and we're really proud to give her this gift. And she says she really likes it. I recommend it. I tried to go buy one and I couldn't even find one. So I'm hoping that either you order them online or they're still available. But to me, I want one. I want one really bad.
What was the price on it?
I think they're like $40 or something, $35. Yeah, they're not bad. Yeah, I mean, the thing that's nice about it, it has pretty much everything you need to take apart a bathroom stall. Like you can just basically take apart anything you want inside of anywhere you want. I mean, because all the tamper selections are there. Now, I don't know personally. 'Cause I know some of those tamper screws, they're not made to come out. They're made to tighten in, and then if you want to take them out, you have to drill them out.
Okay.
So it's kind of a cool thing. I do a lot of fire alarm work. So for me personally, if you're doing fire alarm work, I recommend this 100%. I mean, you'll be able to get into any device that you have, and I like how it's real slender. How the attachments go in there, real slender. Like they thought about going into those terminals because you have to go through a long ways sometimes to go in there, and like a lot of our bigger screwdrivers won't fit through, and so that's kind of what we worry about. But I really appreciate Kirsten for giving me the feedback, and she says she really likes it. So I mean, to me, I want one. I have not actually had one. I saw it, I was like, cool, and then I gave it as a gift for the female apprentice prize, and then now I want one again, but I can't find it. I don't know where they are.
Okay. Oh, no worries.
Yeah, it's a good tool. To me personally, I want one. and I hope you do too.
I think that's pretty awesome that we got all these different tools we're showing on here, and just hearing about the different brands and everything, and how functional they are, if they're not functional, And I sort of dig that. I actually had somebody, I forget what we covered. He, he sent a thing, message. He goes, "I like so and so brand better." I replied, I feel you, brother. Everybody has their certain thing. I texted. I said, sort of like when I'm buying golf clubs, I like certain brands better than others, even though
Yeah.
they're supposed to be comparable. So,
Dude, my dad actually was a golfsmith back in the day,
oh, really?
and he actually made like his own custom clubs and everything. And I mean, you would not believe the amount of stuff that you have to know about building your own custom clubs. And he would build like the best set of clubs ever. And I'd go out there and shoot pretty good with them. I'd be like, yeah, I didn't really like the weight on this or whatever. Next thing you know, he'd build me another set. Dude, I look like a freaking dumbass out there.
Oh,
And
oh,
and it's like I'm more kind of that person. I'm just more like middle of the road. Like I don't need all this high end stuff, like because it's like all this balanced everything, like you know what I mean? Because it was just the balance thing threw me off. Like I couldn't do it. Like, dude, I went out there. Yeah, I got this custom set of clubs. I go up there first thing off the tee, and I freaking shank it like right into the river. You know what I mean? Like, I mean, it was like the worst shot ever. And I was like, what the hell? It's like some like X3 driver, something crazy. And I'm like,
yeah.
it has this really cool name on it, but like when you go out there first thing off the hole, you'll be better off with something off the freaking dollar store or something. And so that's where I kind of got like, I didn't want to do all this like designer stuff anymore. And I shot a pretty good game, a few months ago, and it was just a cheap set of clubs that I found out later was actually a girl set, but it was weighted for a man. So you know what I mean. It was like a tough girl. Like it wasn't a full girl set. It was heavy for a girl set, but I just shot good with it. You know what I mean? And it was like I didn't even know. I just got from like a thrift store or something, and I was like,
Right.
all right, let's go shoot. So
Well, for anybody asks, I'm pretty much a scratch shooter. So,
yeah,
uh,
so
we went and played starting the season, and I didn't go practice or anything before, and I just kept pulling everything just to the left of the green, and I'd either hit the left side of the green or it'd hit the hill and roll off, and that was a high score I shot in a while, and that was a 78.
that's not bad.
So, but usually I
Well, what
shoot
was par for the course?
72.
Okay.
So
Yeah.
I was scrambling a lot getting up and down, but we went and played the other day, and 5 holes in a row, I was within 10 foot of the pin for birdie on 5 holes in a row, and I only made one, and it was the longest putt. All the rest were 3, 4 foot putts, but they were on sort of a slant on the hill, and I lived every cup. I mean, I literally could have shot 5 under just in 5 holes. I just could not get that damn putt to fall.
Um,
And uh,
yeah,
but
I three putt a lot, and that's just
yeah, my
what
friend
happens.
Travis, sometimes he watches these. He's not electrical. If he watches this, he beat me once, and he's actually beat me, I think, 3 times total out of a million. Uh, but I've been teaching him, and boy, I never hear the end of it. He beats me. I just like, okay, whatever, brother. I mean, even the best of the best lose every now and then.
Yeah, I mean, the one thing that I notice about my game is that I have a really good drive off the tee,
Hmm.
and I have a really good landing, like to get on the green. And like sometimes I do like a little, really like not really textbook fundamental way to like get on the green. Like sometimes it's just like a really hard grounder that just kind of like goes up there and gets on there. But it doesn't need to like go like 90 foot in the air and come down. You know what I mean? It's like, just do the little freaking Ricky Bobby and
Right.
just get on the green. Who cares?
That's true. That day he beat me. We were on a par 3 and it was down the hill. He hits on top of the ball and it rolls down and gets speed going. It runs up on the green and it's like that far from the hole, almost a hole in one. I was like, that's a bunch of bull. you played the ball and it goes up there, and I hit a good shot, and I'm 10 foot away, but he blades one, and it's, my dad one time, this is a long, long time ago, and we went up and we were playing True North up in Scottsdale. My dad's not that good, but he hits a ball. He literally slices it, and it hits this big rock and shoots over across the behind the green. It hits another rock, shoots straight up in there, and it landed about that far from the hole.
Oh wow!
And he goes, I bet you can't make that shot. I was like, yeah,
Wow.
I bet I can't.
Dude, I'll never forget my dad it was a long time ago. I was probably like 15, 16 years old. My dad comes up on a par 3 and he freaking hits it. And I swear to God, I couldn't even see where it went. Like it just went straight up in the air. And it comes down like right about probably like 5-6 foot from the hole and just freaking backspins and just almost. It didn't go in, but it was like
Close.
when I saw it, I was like, holy crap. Like being a kid, whatever. I wasn't a kid, but being like a teenager, I was like, how the hell do you do that? Like he had the perfect iron. He knew exactly the distance. Like,
Sure.
He just hit it perfect and he just put it right there. And then he's like, oh, damn it. That should have went in, and I was like, dude, like I would have freak ground balled it and said, oh, damn it. That should have went in. Kind of like your dad,
I've actually had
went off 3 rocks, should have went in,
I've actually had 3 hole-in-ones. And my first one, when I was 20, we were out at Meadowbrook, and it was a 2-tiered green, and the pin was down on the bottom tier, and I hit it up on the top and put spin on it, and it come back. It barely caught that hill, and a guy had just shot one, or my buddy, who was I playing? Glenn. I was playing with Glenn, and Glenn was about that far from the hole, and he turned around and he goes, let's see you get inside that, boy. And I hit it up there, and it came down and went straight in the cup. And I said,
wow.
I said, did I get inside it? And I was so happy when I got to the next hole. I was up there shaking to hit the next drive. And he goes, I'd be shaking too. He goes, you're going to be buying a lot of beer tonight.
Yeah. That's pretty awesome.
Yeah, I'll never forget the first. And then when I made the second and third one, I was like, nah, I've already done it once. That's good enough. So,
how many 8-ball breaks have you had in pool?
2.
2?
I've had 2. I actually had one 2 weeks ago. Then I had one when I wasn't that good about 5 months ago. I just hit it hard and it went in. So
I had 3 in one night.
I remember you told me that.
2 in a row, man. It was amazing because it's like when you get that feel and you're just on and you're just hitting that thing, it's just like, and especially you start knowing the table, you just hit that same shot every time.
You got to be over to the right or left dot the first one. You've got to hit that cue ball dead on that first ball to get it to push and have the back ball come back and hit that 8 ball and move it.
So I learned that. So what I do is I do top left, and then what happens is I hit top left. It hits the 1 ball, then it comes off. It goes over, hits the rail, then it comes off the rail with like super speed, and then it hits the rack like in the side.
You talking about using the cue ball?
Yeah. So the cue ball has like top left English,
Mhm.
and it freaking hits the stack kind of center a little bit, but it's still got that English to the left. And then it goes over, hits the rail, and then kind of comes off the rail with speed and then just hits.
Hits it. That's what I was saying. Yeah.
And then it just like everything in the stack kind of moves out of the way. And then the 8-ball is the only one sitting there, and then just comes off and just cuts it right in the corner.
That's
And
some good shooting there.
I did 3 in a row. Not 3 in a row, but 2 in a row and 3 in one night. Exactly the same shot. And it was awesome. And I've even done it on computer simulation, where I've actually done it on computer simulation, the same exact shot with the same exact English, same exact where I hit it right there, and it's done the same exact thing.
Yeah.
Goes over there and it hits it, goes over, it hits there, everything moves out of the way, and then just cuts it right in the corner.
That's things you get when you're dealing with that spin.
Yeah.
All right. You ready
yeah.
to wrap it up? I'm hungry.
Yeah.
I hadn't eaten since lunch, and I'm telling you, last night I didn't go to bed to almost 2:00 getting all this stuff ready last night. Then I had to turn around, get up at 5:30 today. I'm telling you, I'm exhausted, man, and I'm starving.
Good show, everybody. I really appreciate it. Everyone that's been here, it's really awesome. We've had a great time doing this, and feel free to post, comment, whatever you want. Any of our groups, like, nobody's getting blocked.
Just hit us up. Let us know what you're looking at, what you want. I know it looks like we're gonna have a lot of brand new inspectors coming to the group, so you're probably looking at about 40, 50 that are going to be joining. And they all were excited. They didn't even know we were doing the podcast, and I told them what to do and everything, and I was showing them during break, and they were like, "Wow, man!" He goes, "Y'all got cool graphics." And he goes, "Who does that for you?" I said, "Well, I set it up. I had to figure out." And he was like, "Wow."
We might need some new metal. I might be able to do some new metal for us.
All you gotta do is send it to me. I know how to put it in now.
Yeah.
It took me a week to figure it out, but I finally figured out how to add everything in. So,
all right. Well, we got our new Monday morning coach coming up soon, so
yes, I'm gonna take this weekend. I'm actually gonna go through the software and everything. If we hadn't had the inspector training that was going on this week, I'd have done it this week. But I've been dealing with a lot of that, and Dad did a presentation yesterday on hazardous classified locations, and we may take and get him to do like 2 weeks in a row and show how to go in and do classification. We did that over there, boy, and this is actually what he said today. He had to leave early, but Jerry Daniels said that was the best presentation he's ever seen on hazardous.
Nice.
And that's big compliment, because that's coming from the chief electrical inspector for the whole state of Texas.
Well, I'll tell you what, he gave me a compliment, so I can't really argue with that guy much.
Yeah, he's a good dude. All right, everybody. Let's wrap this booger up, and we'll see y'all next week. If there's something in particular you'd like to see us cover, or you got any questions or anything, how do they say it? Hit like, subscribe, share, ring that bell, whatever the hell they say. And just let us know, and we'll do our best to cover whatever it is you want us to cover, just like we did for the fire pumps. Okay?
Yep.
Other than that, you got anything else?
Well, God bless, stay safe, and we love y'all, man.
Peace. All right, we'll see y'all next week. Everybody have a good week and good weekend. And same bat time, same bat channel next Thursday at 7:00.
Absolutely.
Take care, everybody.